When you go today to a commercial forest, then you will find very little deadwood. But this is not a new story. So the competition between humans and saproxylic organisms is a several thousand year one. It means that in a natural forest there would be plenty of deadwood, but because we always remove wood from the forest, which would remain in the forest and rotten and provide habitat for many organisms.
The idea behind the Lifspan project come from the problems of productive managed forests, such as the periodically disturbance produced by the cutting interventions, the scarcity of deadwood and large old trees, and the lack of forest gap and forest structure heterogeneity. So the main objective of the project is to propose and test management options for such kind of forests, adding deadwood and managing deadwood to increase and protect biodiversity.
The main lack of deadwood appeared during the last 200-300 years, when modern forestry starts. So in the medieval age, there was a different time. Even if the forests were poor of trees, there were still these pasture trees, deadwood attached on trees, used for pasture. But then people started with a really commercial wood production. So they transferred these more natural tree species composition to conifer plantation, fast growing, and there was no room for deadwood anymore. So rotting trees is a very common resource in a natural forest. Therefore, it's no surprise that about 30 to 40% of species belong to deadwood. Some of them are really restricted to deadwood habitat, like saproxylic beetles. They need deadwood to survive.
Deadwood in the forest provides home and nourishment for saproxylic insects. These insects are mainly beetles belonging to the Coleoptera order, but many other insect orders are also linked to deadwood for their entire life cycle or only part of it, or for food reasons, like flies, bugs or ants. Not only they are food for many other animals, but some of them also establish symbiotic relationships with fungi, and many more are pollinators. Strictly saproxylic beetles develop in tree trunks feeding on wood. Some insects live under the bark, and while others are associated with tree holes filled with water. Regarding Coleoptera, there are some representative saproxylic species like Rosalia alpina or Osmoderma eremita or Lucanus cerbus. The monitoring of these species and other insects is conducted with two different window traps. These traps are made of two crossed panels that intercept the flight of insects, dropping them in a collection jar. The first type of window traps has transparent panels, and the insects are collected then sorted in the lab. The second type of window traps has black panels and is activated with pheromones and other volatile compounds that attract target species of Coleoptera that are released after the identification.
The deadwood also provides a lot of nesting or roosting sites, for example for birds or bats. So in these cracks the bats hibernate, or the birds, if you have an old snag, then the Ural owl at the end, short before the whole trunk is falling down because it's so rotten, the female of an Ural owl built his nesting site, grabbing there a nest and breeding there.
Having deadwood in the forest is very beneficial for many groups of organisms. One of the groups that really depend on deadwood are bats. And bats use deadwood, things like cavities in trees or loose bark, firstly as a place to sleep, so they roost there during the day to rest. And another really important function of deadwood for bats is also to provide prey. So the bats will feed on the insects that live in the deadwood. One really good example that we have here is the greater mouse-eared bat. They are specialized on feeding on beetles, and deadwood attracts a lot of beetles and is important for beetle species, so these bats will come down and eat the beetles off of the deadwood. Another bat that really depends on deadwood is the western barbastelle, and this species really requires a forest with a lot of different structures, deadwood, old trees, so that they have a lot of roosting possibilities. And this is a rather rare species for this area, but it's important to have that in the forest.
Beyond the vertebrates, the most diversity in deadwood is not about animals, it is about microbes. As we can see here, the flowering fungi and also the bacteria, they form the majority of species. And this was for a long time a hidden world for us as scientists. So we were able only to count these sporocarps and to identify them. This was fine. But nowadays we can drill the wood and analyze the sawdust by genetic methods. And just as an example, a log like this, if you count all the sporocarps or the species via the sporocarps, you will end up maybe in 20 species or 40 species. And if you drill, you will have the 10 times more species. So many of the fungi are inside doing no sporocarps or building no sporocarps at all. However, deadwood is not only important as a habitat for species, it's also important for ecosystem functions. So for example, deadwood, as I'm sitting here, retains the water. Because rotten trees are like a sponge. They really capture and keep the water in the forest. Then it provides an important nutrition pool for other organisms to grow, like plants.
Plant species play a fundamental ecological role in forest ecosystems, especially for saproxylic fauna. First of all, the herb and shrub layer maintains soil moisture and regulates temperature, creating optimal conditions for the decomposition of deadwood by arthropods, fungi and bacteria, and prolonging its availability as habitat for saproxylic species. This promotes the accumulation of organic matter and nutrient recycling, acting as a catalyst. It boosts biodiversity of flowering plants, which support pollinators and saproxylic insects, in turn attracting insectivorous birds and mammals. Naturally, leaf biomass and fruits provide essential nutrition for birds, small mammals, ungulates and reptiles. In addition, grassy and shrubby zones also serve as foraging grounds for bats and as a site for social behaviors of animals like, for example, deer, and these reinforcing population stability. So, the herb and shrub layer is not mere ground cover, but it is an ecological engine. By promoting diversity and connectivity, it sustains saproxylic species and the fauna depending on them. Conservation strategies must, therefore, integrate the management of herb and shrub to preserve forest biodiversity as broadly as possible.
So in a natural forest, deadwood is all over the place. In managed forest, we lack deadwood, and there it needs a specific management. We have to have a targeted management which provides all these kind of deadwood over time and space. And this is in a commercial forest only possible if you do it also actively, if you intentionally leave it, or if you girdle a tree now that it will decay in 5 years and then be suitable. And to provide in the sun and in the shade and small pieces of deadwood, but also large and different tree species. It's not the pure amount which is important, it's the diversity, which is economically an important message. Because if you are clever as a forest management, you can still use your forest, but have a high diversity of deadwood organisms.
In two forest sites in Italy and in Germany, we realized micro reserves that inside the project are called SHS, saproxylic habitat sites. These reserves are finalized to support saproxylic species.
So the idea of the original SHS is to enhance heterogeneity in managed forests. Each SHS is divided into 3 sections. One section in which we did a thinning to favor future habitat trees and already major trees. A second section where we created a gap to enhance the light on the ground, and the third section where we created microhabitats on trees and deadwood. We did this in different ways. For example, we pollard trees or we girdled trees. We cut down trees and left the whole tree on the ground, or we uprooted a tree like this one here. The SHS has been integrated in the forest management plan. We still have the opportunity to harvest trees that are strong enough to be harvested. So it's not an exclusion, it's integrated in the managed forest.
So here we are at the University Forest Office Sailershausen. We manage a forest that's property of the University of Würzburg since 1582. So we focus a little bit more on research, but we still are a commercially managed forest enterprise with the aim of generating income for the university, but with a high degree of ecological considerations. There was a profound change of management in the 1960s. A lot of the old forest has been cut down and they tried to replant it with conifers. And unfortunately from this time we have a considerable area that consists now of more or less even-aged younger stands, younger than 70 years, that are very homogeneous, that don't offer many niches and many structures that you can find in old growth forests. And due to that, we are thinking of how we can structurally enhance our forests to offer better niches. And these SHS, they are really perfect tools and perfect pieces of how we can enrich our forest structure.
This SHS has to be considered as a node of a network connected by habitat trees. This network works like a reservoir of biodiversity from which, after each disturbance, the biodiversity restarts its colonization.
Integrating a saproxylic habitat network into a managed forest isn't just a technical step. It's a deliberate choice in forest planning. It begins with understanding the forest, the stand, the amount of deadwood, and the most ecologically important areas. From there, we design a network deciding how many SHS, their size, and how they should connect to keep life flowing through the forest over time. We are not simply creating protected zone. We are building a living, adaptable system that changes, grows, and supports key species essential for forest health. To be successful, we need to ask the right questions. What's the minimum size for an SHN? How many SHS do we need and how far apart should they be? What's the time frame? Should the network be permanent or flexible? And most importantly, how do we include it in the forest management plan? Our goal is to answer these key questions using the results of the Lifspan project, because a resilient forest starts with a connected forest.
Fortunately, within the Lifespan project, we have installed 2 more telescopes also. And one of them we use intensively for forestry training. I think this training is very important to make some deficits visible that usually forest managers and private forest owners have with respect to deadwood and microhabitats. Usually these are structures that are not on the agenda when doing silvicultural treatments to forests. And within these smart telescopes, there is a really good opportunity to make these visible and to communicate how important they are.
We of course try to involve as many students from the university as possible, so we offered several bachelor or master theses, for example, how those interventions and the treatments affected insect diversity in the forest. Then we offered different teaching activities for graduate and undergraduate students, where we had like an active outdoor classroom here and had several exercises, finding different microhabitats and like making the whole project more visible for our students.
And sometimes it's even foresters with a long routine in forest management, they very often overlook very important structures like microhabitats. And so we help them to develop an eye for this.
To be honest, it can look a bit chaotic here, but when we invite the people to come to us, when we have public events, we can like teach them the purpose and like talk to them, go into discussion. And then some of them said to me, "What? I didn't know that, for example, moths do live in Deadwood. That's great." And so I think we can like do a lot and change a lot simply by offering discussion.
In the late 1980s, leaving deadwood in a forest was forbidden. It was a shame for foresters. And this has dramatically changed, even by a project like this one. And the reason is that foresters more and more recognize deadwood is an important feature of the forest. So nowadays we see no discussion about the general value. Now the discussion is more about how, when and where.